Okay, welcome back. Now, what I want to look at today is so let me just make sure that my mic is not covered over. Okay, bear with me for a moment. Okay, I think that should be okay. Okay, right now again, this video is for you simply to listen to if you prefer that. But what I want to look at today is something called basic mechanics. Okay, and when we go into basic mechanics, what we're looking at things like the gravity, the gravitational forces that acts upon an object. We're looking at the how to calculate an area or find the center of gravity where certain things are. We might look at if we take up, for instance, an object with a high center of gravity, it will remain more stable than if this gravity was off center. Okay, so that's what I want to be looking at for today. Okay, right, I'm going to leave you now, and again you need to look at the video called, let me make sure I'm giving you the name correctly, Basic Mechanics 2. Okay, this is for session 3 and this is Basic Mechanics 2. So when you look at the video and you go for the video, look at the heading. It's in the heading and it tells you there. Either it'll be on the first slide or on the second slide. Okay, either on the first slide or on the second slide. Okay? And that's important for you to know that. Okay, let me just see how, if I'm still looking handsome, I'm good looking as normal. Okay, yeah, yes, I'm still handsome, good looking. That's me, but I gotta get some teeth. Okay. Okay, let's get cracking. Bear with me for a moment while I get organized and set up. Because sometimes it doesn't always go like as I would like it to go. Instead, come ready. No. Okay, take off. Come on. Come on, from here. Give me. Yeah. And you. Okay. No, I don't want to wipe out. Okay. Okay. I don't want to wipe out the yet. Okay. Okay, let me just see if I can. I like it. I do. I like it. You. You're looking good. Hang on. Okay. Am I square? Am I line up? Nope, not line up yet. Bear with me for a second. Sometimes it doesn't do what it should do. Yes, I'm not. No. So okay, I've got to get the camera in line, otherwise it gives me a kind of leaning top of pizza kind of thing. Okay. Welcome back. And we're looking at, again, Sittingill's work, okay? And what I want to look at is section 3, basic mechanics, okay? Basic mechanics, okay? Let me just pan back a bit, make sure we can get that in. Okay, I don't want anything left out. Let's just go and make sure we get everything into view. Okay, basic mechanics. Aims and objectives of this session here, to be able to understand what is meant by stability and center of gravity, to be able to understand what is meant by balance and turning moments, to be able to understand what is meant by mechanical advantage and velocity ratio, work, power, and efficiency. Okay. Okay, just a general review showing you what we've done previously, and you will find a lot of this already on a number of my videos already. So look through the videos, okay? Mainly look for the heading that's closest to what you have in mind, and you should be able to come across what you want, okay? Right, here we have center of gravity and stability. The center of gravity is the point through which all the weight of an object appears to act. The center of gravity on a rectangle is the center of the rectangle. Center of gravity of a circle is the center of the circle, and that would be your center of gravity. Now, if you move the center of gravity, then you're going to create a weight shift which will cause an imbalance. Therefore, your object may well fall over. So keep that in mind. Here, less simple shape. So we have L shape here. Less simple shape have to be calculated. On the diagram below, you can see that the center of gravity is not in the shape itself, but it is off center of the object. And we look having a right angle. Imagine this to be a right angle ruler, a builder's or merchant's ruler, metal ruler, with a 90-degree angle on it shaped. The center of gravity affects the stability of the object, okay? Why are we concerned about center of gravity? Because it will cause a change to the object you're dealing with, and it can cause the object to be balanced or unbalanced. Therefore, you always want your objects to be balanced. Now here we have center of gravity, high center of gravity, okay? Object unstable when incline. Now, if you put an object on an incline, you have to then try to find the center of gravity, but that center of gravity will change. Therefore, your object will be in a position where it may well topple over. Be aware of that. An object with a high center of gravity, like a tower or scaffold, cannot tip very far before it will topple over, okay? Usually, the lower the center of gravity, the more stable something is, okay? So imagine a bus. For instance, the center of gravity of the bus has got a low center of gravity. That's why it doesn't topple over when it's going around a corner to any degree, provided it takes the corner at a reasonable speed, okay? Now, intersection points. Now, sorry, let me just come back a bit. Yeah, okay. Now, to find the center of gravity of an object, you can draw a line from all of the outer points and the point where they all meet is the intersection point or point of the center of its gravity. Other intersection point or plates, rectangular plate is at the intersection of the diagonals. Circular plate is at the center. A sphere is at the center. Cylinder is at the midpoint of its length. Now, other factors affecting the center of gravity are its weight and the width of the supporting base. Have you ever wondered why tall tower 10, 20, 30 story building stands up? Sorry, okay, a block of flats, for heaven's sake, okay? Have you ever wondered why a block of flats stand up and doesn't topple over? Because a lot of work has gone into maintaining its center of gravity, okay? And that's what is the relevance of this. Okay? Now here we have something called equilibrium. Equilibrium. Now, this is where a body remains in a particular state until an external force acts upon it or causes it to go out of balance. And here we have a lamppost, for instance, and we have supporting cables here to keep it balanced. Okay, then we have our pylons going out, etc. And we have forces being exerted on at this point. Now, those forces will increase due to wind factor, especially if they're like 100 meters long, as you've seen them when you're going along the motorway in regard to pylons or your wooden post carrying your telephone cables. A stable equilibrium is when a force is applied and it returns to its original position. Okay? Here we've got a pylon. And the pylon has no support, no balance, but it has got a force exerted on at this point. And what has happened here, it has snapped. Because there's no opposing force to retain it in position, it simply has toppled over. An unstable equilibrium is when a force is applied to the object, it will continue to move away from its original position. And that force will cause it to collapse. And that is in reference to equilibrium. Now let's look at turning moments. What is turning moment? What are we talking about? We're talking about turning moments. Another word for turning moment is torque. We're talking about the torque or the force required to move an object or to rotate it. Torque is the turning force applied to an object. Steering wheels, car wheels, spanners, and wrenches all have torque applied to them. The magnitude of the turning force or torque depends on the distance away from the object, the amount of force applied. Now here I'm showing you a spanner, okay? And it's attached to a nut. Now if I make the spanner 1 foot long and I try to undo the nut, I would have to apply more force to that 1 foot long spanner to undo the nut. But if I made the length of the spanner 3 feet, the force I would require to undo the nut becomes less, far less. I could almost just tip the spanner up and the nut would come off because of the shear, because of the force being applied due to the length of my spanner. So in short term, from my perspective, and it's from my perspective only, the longer my spanner is, the less force I need to apply to undo the knot, because the spanner would apply that force from myself, from me to itself in a more effective and proficient effect in making my knot come loose. Okay. It's okay. I'm just trying to get it so that it applies or makes little sense. But remember, you will need to do this for yourself, because you will have to have your own style of learning as well. Okay. And you will need to adapt that for yourself. Okay. The unit used for torque is Newton meters, Nm. The symbol is T. Torque. Torque can be determined using the following equation: T equals force times distance. I repeat, T equals force times distance. Okay. So the longer my spanner, the less force I need to apply to the knot to get it undone. The shorter my spanner, the more force I will need to apply to the knot to get it undone. Torque on an object is the distance from the turning point and also the perpendicular distance from the turning point. Okay, so we have force least torque when the spanner is in this position. Okay, etc. Okay. Now we're looking at what we call mechanical advantage. Mechanical advantage is when we use a tool or machine to do some work for us, for example, a winch or jack or a stacker truck. Mechanical advantage is the ratio of load to effort applied. Mechanical advantage, MA equals load over effort. Okay, MA equals load over effort. Load is measured in newtons as well as effort. There are no units for mechanical advantage. The larger the mechanical advantage, the easier it is to move a load. To get a large mechanical advantage, it is necessary to have the effort applied over a longer distance than the load is moved. Again, back to making my spanner longer from 1 foot to 3 feet, that will give me a mechanical advantage. This means that a second measure is used. This is called velocity ratio. Now, what is velocity ratio? Velocity ratio is the ratio of distance moved by the effort applied to the distance moved by the load. Okay. In short term, it is the distance I've moved the load from one stationary point to another. And in moving that object, I have exerted a velocity ratio. Because now velocity ratio equals distance moved by effort over distance moved by load. There are no units for velocity ratio. It is usually a constant term, whereas mechanical advantage may vary with load. Okay. Kind of like this actually. I hope you find this useful, because this information is so important and plays such a vital part in electrical engineering work that you guys should make the most of this, because this is given to you free. It's not, there's no charge for this. I don't get paid here. If only I did. But never mind. But the interesting thing is that I enjoy what I do. I like my vacation, if you like. Okay, so I hope you will find this useful. Whether you do or not, I will still continue anyway. But just to let you know that what you do now can shape your future. So make the most of it. Work is done whenever a force is applied to an object, causing it to move or deform. The amount of work depends on the amount of force being applied and the distance the object moves. The symbol for work is W and the unit is the joule. Energy and work are related. Energy is a capacity to do work. Work is equals work equals FD. Work equals work W equals work done or energy. F equals force in newtons and D equals distance in meters. Okay. And so I was getting tired of my teeth there then for a moment. Power. Power is the rate at which work is done. Once we introduce the term rate, we are dealing with time. The symbol for power is P and the unit is the watt. There are two formulae for mechanical power. The basic one, P equals W over T. P equals power, watt, W equals work done, Newton meters or joules, T equals time in seconds. Now, efficiency. Efficiency is the ratio. It compares what goes in with what goes out and gives us some idea of the losses or waste. Efficiency is the ratio of power or energy into power or energy out. Efficiency, your symbol, equal energy output times 100 over energy input. And again, similar for the thing here. If we didn't multiply by 100, we would get the answer per unit instead of a percentage. Okay. Okay, I hope you found this useful. And I can't click back on you, so okay. We found this useful, and I hope you have a quiet. Now, let me just see if I can work my way back up, make sure that it has all been seen. Okay. Okay, but I believe it is all clear. Okay. Thank you. Have a good day. Bye-bye. I hope that you may have found that useful in one way or the other. Don't forget to look at the video itself, okay? Because then you can then see what I'm talking about. Okay? Have a good day. Bye-bye. Have a good day. Bye-bye.